Okay, we're going to talk about something called scientific notation. And our goal is going to be to convert numbers to and from scientific notation and then to perform calculations using this notation. Scientific notation is used, as you might guess from the name, in a lot of science settings for a very specific reason. You often run across numbers like .0000002 and related numbers, or numbers like this one. And instead of using commas, I'm just separating the groups of 3 with spaces. And there are a lot of placeholders in these numbers. These are very inconvenient to work with. You have to keep counting zeros all the time. So what we'll do is we'll write these as a product instead of writing them out in this manner. And we'll work with numbers a little more convenient than those for the sake of this lecture. So, for example, you have a number like 53,000. We could write that as 5.3 times 10,000, and you can multiply that out to check it. We could take a number like, not quite as bad as the one I started with, got 5 zeros and a 2. That's 2 1/millionth, which is still a lot of zeros, which is 2 times 1 over a million. And that's beginning to get a little bit better, but we still have a lot of zeros to work with, and we'd like to eliminate them. So we're going to bring in those exponents to help us solve this problem. Well, let's consider tens and multiples of 10. I could write 10 as 1 times 10. But, let's see if I can fit this all on here. That's 1 times 10 to the first power, because any number to the first power is just the number. I could write 100 as 1 times 10 times 10, but I have 10 to the second power here. 1 times 10 to the second power if I look at the 10 times 10 part. And similarly, I could go on with 1,000. That's going to be 1 times 10 times 10 times 10. And that, well, looking at the tens again, we have 10 to the third power is 1 times 10 to the third power. You will notice that the number of zeros is the same as the power on the 10. And that's a very convenient thing. We're going to use that. Let's also look again at the problem 2 times 1 over a million. We have 6 zeros, so we could write that as 2 times 1 over 10 to the 6th. But we'd really rather not haul around a fraction. So what we'll do is we'll take our definition for negative exponents and we'll just go in reverse. And we can write that as 2 times 10 to the negative 6. If we have a number that has a positive power cross the line, we'll make the power negative, just going in reverse. This is a number written in scientific notation right there. We started out with, what was that, 5 zeros? 0.0, 0, 0, 0, 0, 2, and wrote it as 2, the non-zero digit, times 10 raised to some power. And that's where we're heading in scientific notation, getting rid of all those zeros by writing things as products. Let's go back and look at that 53,000 again. I told you before we could write that as 5.3 times 10,000, but instead of hauling around, yes, it looked funny to me for a moment. Instead of hauling around 10,000, we have 4 zeros, so we're going to write that as 5.3 times 10 to the 4th. Now, we're looking for a recipe. To make this practical when you're working with experiments or whatever you're doing, we would like to have a recipe for this, so let me give you one. Our recipe is going to be, first of all, to place a caret to the right of the first non-zero digit we see. So the first number that's not 0. Well, digit that's not 0. So looking again at the 53,000 and the 2 millionths. And again, colored pencils or pens are helpful as a visual aid when you're doing your homework too. We would put a caret to the right of the first non-zero digit going from left to right. So the first non-zero digit we run into is a 5. Put a caret right next to it. On this number, traveling again from left to right, just as we read from left to right, zeros, nothing but zeros, 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 2. Put a caret right to the right of the 2. Our second step in our recipe is going to be to count. And we're going to count how many places you will be moving the decimal. As you'll notice when we wrote, if I can go back up here, 53,000 as a 5.3 times 10,000, we were moving the decimal point. We used to have a decimal point here at the end. We moved it over and wrote a basically a mixed number times a whole number. We'll count how many places we will be moving the decimal. Now, what that's going to accomplish for us, remembering that we're after writing a number times 10 raised to some power, that's what scientific notation does for us, is it gives you the power. It gives you really the absolute value of the power. So I'll put those wonderful little absolute value symbols down, lines down to indicate absolute value. But it does not give you the sign. In other words, is it going to be a positive or a negative power? 53,000, we had a positive power. 2/millionths, the fraction, we had a negative power. So what we're going to have to do is either recognize that we're working with a fraction or recognize that we're working with a number that is greater than 1 that's not a fraction. The absolute value of the number is greater than 1. Pardon me. I don't have a good memory device for this, but what I can tell you is that if your decimal is moving left, you'll have a positive power. And if your decimal, that's our third step, is putting the sign on it, moves right, you'll have a negative power. It's kind of backwards of how you might normally think with signs.